Yann LeCun, one of the primary architects of modern AI, believes ChatGPT is hitting a wall. He argues that these systems aren't actually intelligent. They are highly advanced statistical mirrors, memorizing sequences of words and pixels without grasping the reality behind them. The inefficiency becomes obvious on the road. A 17-year-old can learn to drive a car safely with about 20 hours of practice. To achieve the same proficiency, an artificial intelligence system requires millions of hours of driving data and thousands of edge case examples. This gap exists because humans possess an internal world model. We have an intuitive understanding of physics and cause and effect that allows us to generalize from a few experiences, while current AI must see every possible scenario to understand it. If you want to understand the logic behind the technology of the future, click that subscribe button. 97% of you watching right now aren't subscribed, and I'd love for you to join us as we deconstruct these shifts. A billion-dollar race is now underway to map that human-like world model into a machine. Success would likely make every generative AI model we use today obsolete. To understand why AI struggles with the physical world, researchers point to a specific failure called the blurry frame problem. Imagine asking a model to predict the next few seconds of a video showing a bouncing ball. Generative models attempt to solve this by predicting the exact color and coordinate of every single pixel in the next frame. It's a brute force approach to a problem that contains infinite variables. Because the ball's exact trajectory has a degree of uncertainty, the AI gets overwhelmed. It tries to account for every possible path by averaging the outcomes, which results in this smeared, chaotic visual mess. Human psychology offers a more efficient path. Your brain completely ignores the background pixels and the lighting changes. You focus entirely on the abstract information, the gravity, the surface, and the trajectory. This architecture, known as JEPA, or Joint Embedding Predictive Architecture, attempts to replicate this abstract filtering. It aims to encode the core features of a scene into a mathematical embedding, rather than drawing every pixel. Engineering a world model means shifting the goal from perfect visual reconstruction to accurate physical filtering, ignoring the noise to focus on the variables that drive the next action. This raises a central engineering question. How do you teach a computer to develop that kind of abstract intuition? Yann LeCun uses a cake metaphor to classify AI layers. The cherry is reinforcement learning, learning through trial and error. The icing is supervised learning, using human-labeled data, where models like ChatGPT exist. But the massive base is self-supervised learning. This is how children learn, simply by observing the physical world and identifying patterns without any explicit labels. They learn the rules of gravity and distance by watching the universe operate. To reach true intelligence, machines must move past being force-fed feeling words and start watching the rules of the physical universe for themselves. Before we go further, I want to hear from you. Type yes or no in the comments. Will AI ever achieve true common sense? While we wait for world models to arrive, researchers at the MIT Media Lab are looking at what our current tools are doing to us. They've identified a concept called cognitive debt. In their study, participants who used AI assistants for essay writing tasks showed measurable drops in behavioral and linguistic performance. The neurological consequences were even more stark. Relying on an autocomplete tool showed weakened connectivity across the brain's neural networks. The users effectively under-engaged their own prefrontal and parietal areas. A machine that mimics syntax provides an illusion of intelligence, but a system that models reality provides a platform for planning and navigation. The MIT researchers found that this reliance led to consistent underperformance across neural and linguistic metrics. It suggests that while LLMs provide immediate convenience, they can come with a measurable cognitive cost. A functional world model enables a methodology called optimal control. It is the transition from just predicting words to predicting the physical results of an action. Think about a robotic arm reaching for a cup in a cluttered, real-world environment. This diagram shows JEPA in action. It simulates the consequences of multiple vector paths within its internal model before executing a single movement. The system imagines outcomes, discards paths leading to collisions, and isolates the most efficient sequence of actions. Let's test your own world model. Look at an object across the room, close your eyes, and mentally map out the exact movement needed to grab it. If you can visualize that sequence perfectly, type sync in the comments. The focus of artificial intelligence research is moving past the prediction of the next word. The current engineering push is toward machines that can anticipate, plan, and physically navigate reality. The goal is to build machines that understand the world, not just machines that memorize it. Subscribe to see how that bet plays out.